What is coupling? Coupling is a device used to connect two shafts together at their ends for the purpose of transmitting power. Right? Shafts are usually available up to 7 meters length due to inconvenience in transport. In order to have a great length, it becomes necessary to join two or more pieces of the shaft by means of the coupling. Okay, the shaft couplings are used in machinery for several purposes. The most common of which are the following. First point, to provide for the connection of shaft of units, those are manufactured separately, such as a motor and a generator, and to provide for the disconnection for repairs or alternation. Right. Second one, to provide for misalignment of the shafts or to introduce mechanical flexibility. Then, to reduce the transmission of shock load from one shaft to another, right? Then, to introduce protection against overload, and it should have no projecting parts. Then we are going to discuss types of shaft. Generally, we have two types of shaft, types of coupling, right? First one is rigid coupling. Second one is flexible coupling, right? What is rigid coupling? Rigid coupling is used to connect two shafts which are perfectly aligned, right? It can be classified in three types. First one is sleeve or muff coupling, clamp or split muff coupling, right? Then flange coupling. At first, what is flexible coupling? Flexible coupling is used to connect two shafts having both lateral and angular misalignment, right? It can be classified into three types. First one is Bush pin type coupling, universal coupling, Adams coupling. This is muff coupling, right? That figure is shown here. Okay. Capital D is the outer diameter of the muff, right? Then capital L means length of muff. Small d is shaft diameter, right? Here we have three parts. First one is muff, second one is shaft, and final one key. Okay. It is the simplest type of rigid coupling. Okay. Generally, it's made by cast iron. Okay. It consists of a hollow cylinder hose. Inner diameter is the same as that shaft. Right. It is fitted over the end of the two shafts by means of a Gibb head key. Okay, here the power is transmitted from one shaft to another shaft by means of the key and sleeve. All the elements must be strong enough to transmit the torque. If you want to find the outer diameter of the sleeve, means capital D equal to 2D plus 13 millimeter. Right? If you want to find length of the sleeve, means capital L equal to 3.5 D, where D is the diameter of the shaft. Okay? How to design for sleeve? Okay? The sleeve is designed by considering it as a hollow shaft. Let capital T equal to torque to be transmitted by the coupling. Right? Tau C means permissible shear stress for the material of the sleeve, which is cast iron. Okay, so the value, the safe value of shear stress for cast iron may be taken as 14 megapascal. Torque transmitted by a hollow section means we know the torque formula capital T equal to pi by 16 into tau C within bracket and d power 4 minus small d power 4 divided by capital D. Okay. Here that is equal to pi by 16 into tau c into d cube within bracket 1 minus k power 4. Right? K means k equal to small d power capital D. Right? From this expression, the induced stresses in the sleeve may be checked. Right? By using this formula, we can check the induced stresses in the sleeve. Right? Then we are going to design for key. Right? The width and thickness of the coupling is obtained from the proportions. The length of the coupling key is at least equal to the length of the sleeve. Right? The coupling key is usually made into two parts so that the length of the key in each shaft. The length of the key, small l equal to capital L by 2. That means 3.5d divided by 2. After fixing the length of the key in each shaft, the induced shearing and crushing stresses may be checked. So we know that torque transmitted for shearing of the key equal to L into W into tau into d by 2. Right? If you want crushing of the key means capital T equal to L into T by 2 into sigma C into D by 2. This is the suitable formula. Right? Thank you.